We arrive at the main goal of this section, solving rational equations. That is, we'll have equations with rational expressions, so all the arithmetic that we've been working on we're now going to apply. For a checklist, okay, so the strategy is going to be, we have several fractions in an equation. Our goal is not to try to get all those fractions combined into one term. Instead, I want to take out all the denominators. So if two things are equal and we apply the same operation, what comes out stays equal. So I'm allowed to multiply through to get rid of all the denominators. So we find our least common denominator. We multiply every term in the equation by the least common denominator. For the fraction parts, we'll put it over a 1. Then, once all the denominators are cleared, we're just going to solve. It's just going to be a polynomial equation. Finally, we check and discard. So because we have fractions, we have to worry about dividing by 0. So some solutions, it's possible they come out of our work, but we're not allowed to use them because can't divide by 0. Now, for basic example, let's try x plus 5 over 5x plus x plus 7 over 4x equal to 1. Here, first step, I want to clear those denominators out. Least common denominator is going to be 20x. Okay, so 5x, 4x, 5 and 4, I'm going to need a 20. The x's are fine as they are. I multiply each term by 20x over 1, or just 20x if no fraction. X plus 5 and x plus 7, we be careful with. We put them in parentheses. We'll need to distribute when we do our bookkeeping. Now, for our next step, the denominators are going to go away. 20x over 5x is a 4. 20x over 4x is a 5. And now we're just dealing with a linear equation. So we distribute the 4 and 5 through the parentheses. And what comes out is 11x equal to 55, or x equal to 5. Now, important next step. What's enough for at least a basic check is to check the denominators. If we put 5 in, we get 25 and 20. So neither of those is equal to 0. We could stop here if that was good enough for us. If I wanted to check numerically, okay, we'll put the 5 in the whole thing, which would give 10 over 25 plus 12 over 20. We can reduce these to 2/5 plus 3/5. What comes out is a 1, and so that's a full check, and that works out. Now let's try x plus 2 over x plus 6 equal to x minus 3 over x plus 5. Here, I could just cross multiply to get rid of the fractions, but let's use our previous method. So the LCD is going to be x plus 6 times x plus 5, multiplied by the LCD over 1 on both terms. On the left-hand side, the x plus 6's go. On the right-hand side, the x plus 5's go. So we know we get exactly what we would have gotten had we cross-multiplied. Now we multiply everything out, so we'll get x squared plus 7x plus 10 equal to x squared plus 3x minus 18. That goes to a 4x equal to 28, or x equal to minus 7. The short check is, well, our denominators are x plus 6 and x plus 5, so with minus 7, we're not going to divide by 0. For a strong check, okay, we check numerically, I'll have minus 5 over a minus 1 equal to a minus 10 over a minus 2. That's just going to be 5 equal to 5, so this checks out. Let's try one where we need to solve with a quadratic. So I'll try x over 4 plus 16 over x equal to 5. Right away, we see the LCD is a 4x. So we multiply all terms by 4x over 1. For the 5, we can just multiply by 4x to get 20x. Now we cancel. What's going to be left over is x squared plus 64 equal to 20x. Move the 20x to the other side. We have x squared minus 20x plus 64 equal to 0. That factors nicely. So we have x minus 16, x minus 4 equal to 0, or x equal to 4 and 16. We go back to the original. Okay, we note 4 and 16 are going to work fine for a weak check. We're not going to divide by 0. For a strong check, when we put our numbers in, we're going to have, okay, we put in a 4, 1 plus 4, which is equal to 5, so that works out. If we put in 16, we get 4 plus 1 equal to 5. That checks out also. We now look at some cases where we have to throw solutions away. For instance, if we have x over x minus 1 equal to 1 over x minus 1 plus 2, LCD is x minus 1, so we'll multiply through with an x minus 1 over 1. The 2 just gets an x minus 1. We cancel and we get x equal to 1 plus 2 times x minus 1. We distribute. That's going to be a 2x minus 2. When we clean up, we get x equal to 1. Now if we stop here, we're going to be in trouble because if we check, putting a 1 in, we're going to get a 1 over 0. I automatically stop. 1 over 0 is undefined, and I'm not going to get anything sensible out of the check. Common error is to notice I've got a 1 over 0, 1 over 0. We can cancel them out. It'll still break the check, but that's not good technique. Okay, once you see the 1 over 0, you can just stop right there. So the answer to this, we only had one candidate for a solution. Didn't work out, so no solution. Example with a little bit more going on. Let's try 2x over x minus 4 plus 8 over x plus 4 equal to 64 over x squared minus 16. Now, we have a difference of 2 squares. The x squared minus 16 is x plus 4x minus 4. So for the LCD, we only need the x plus 4x minus 4. We multiply through by the LCD over 1. When things cancel out, what we're left with is going to be 2x, x plus 4, plus 8, x minus 4 equal to 64. I'll move the 64 to the other side. We'll distribute. When I clean up, we can pull a 2 out in front, and then I'm left factoring x squared plus 8x minus 48. That's going to go to x minus 4, x plus 12. Okay, and so set equal to 0, we get possible solutions 4 and minus 12. For a weak check, the minus 12 is going to go through fine. We're not going to divide by 0, but with the 4, we wind up dividing by 0, so I have to throw away the 4. So my only solution here is going to be a minus 12. For the strong check, okay, we'll put that in, then we get, in the original equation, a minus 24 over a minus 16, plus an 8 over a minus 8. Well, that's going to be a 3 halves minus a 1, which is a half. I go and check the other side, and that's going to give me a 64 over 128, which is again a half, so that checks out. So here, only one solution.